All right, so now I'm going to show you guys a few models. I'm going to explain to you what makes them good candidates or bad candidates for 3D printing, how to export them, and then how to scale them and position them in Cura. So this is my demo file. I've got a couple of models here. The first one is this hand. This hand is a pretty good candidate for 3D printing. There's a few qualities about it that I really like. The first one being that it has a flat bottom to it. This means that there's going to be a surface that I can position directly against the build plate. The first layer in our 3D print is our foundation, and it needs a very solid first layer if you want the rest of the print to go well. The second thing that it has going well for it is that there are very few, if any, overhangs. The most overhang that I have here is this slight overhang for the thumb, but even this is not enough to need to generate support. And also it is a watertight object, and that means that there are no open gaps, there's no naked edges, and it is a solid closed poly surface. So if I need to figure out if my surface is good to print, I can click on it and type the command what, and we're going to see a couple things up here, but I'm going to skip down to this geometry tab and see that it is a valid mesh and it is a closed polygon mesh. The two key words that we are looking for here are valid and closed. That way we know that there are no exposed edges here. So the hand is a great one. Let's export it and see what it looks like getting it into Cura. I'm going to type the command export because my hand is selected. The file type that I want to export is a .stl. And the naming convention here is important. This is because the computer that takes the 3D print files is going to be used by everyone. And if you forget to come by and pick up your print, we have a name attached to the file that we can contact you on. So I'm going to type Branham _Matt _hand. I'm going to hit save. I do want a binary file that is great. Hit OK, and it says it was successfully saved to the desktop. So here's my file, and I'm going to open up Cura. All I have to do is drag and drop it in here. If the file were to come in a little bit wonky off to the side or something like this, this is not a great way to start the print. You can see all this red area is where it's going to need to create support material to begin to build the object itself. So instead of trying to finagle it and get it tilted the right way, there's this command over here that says you have these little options here, which is moving, scaling, and rotating. The rotational tab third over says select face to align to the build plate. And so since I have this flat face here, I can click on that and then click on that flat face right there, and it has immediately snapped the hand into printable orientation. If it comes off to the side, or if it comes in sort of like out here in space, you can right click on it and say center selected model, and that will also bring it to the center. So that's looking pretty good. Let's take that off of there and look at our next model. Next one here is we have this mug. Things that make this mug a good model. First is that it has a flat surface to it. Second is that it's a valid and closed poly surface. So that's great. It does have a little bit of overhang, a little bit underneath here, but I don't think that's going to be a problem. What we're really looking for is any very sharp cantilevers. This right here is going to require support material. So I'm going to export that and show you what that looks like. Again, the same naming convention, last name, first name, and what it is. Cool. And so what it does when you have a NURBS model is it will create a mesh for you to export. Again, a binary file is great. And it is saved to the desktop. So let's drag and drop that in there and open up these settings here. And what we're going to want to do is we're going to want to make sure we have support, because I know that that handle is going to overhang a little bit. But also if I roll underneath here, you can see that Cura is telling me that I'm going to need support by this red indicator right here. So I'm going to hit slice so you can see what that looks like. And then preview. And there you go. You can see right there on the side. I'm going to have all this support material being built up. There is a little bit around the bottom too, because that the beginning of the mug itself is a little bit steep. So I'll have to break that off and probably sand it down a little bit after the print. But the mug, I think, makes a great candidate for 3D printing. So the next two models are a little bit less than great 3D print. The first one is this tower. Anything that has large horizontal surfaces stacked that have negative space underneath them are going to be a little difficult. Also, these thinner supports are going to make for this object to be just a little bit hard to print. So let's look at why, though. Again, with a naming convention, last name, first name, and what the model is. All right, so it looks normal. Things appear okay. But when we slice it, this is where problems are going to arise. It's going to be a solid block of plastic. That is because each one of these horizontal planes is going to need support material everywhere where it's going to build, which is the entirety of the model itself. If you were to print this, you're going to get a lot of issues in this support material too, where it connects to these beams, because these are such thin locations that when you have to break the support material away from this, it's very likely that you are going to break this off. At the end of the day, this is plastic, and so it has the ability to be pretty fragile, or at least pretty brittle. I wouldn't suggest to 3D print this. I think I would look at other possible ways of prototyping this object if it needed to be 3D printed, though. We could talk about ways of breaking this down. I think if you wanted to, you could turn each one of these horizontal planes into its own object. You could remove these support facades and lay them down flat, and then possibly break the whole thing up into a bunch of smaller objects that could then be reassembled post-processing. But all in all, really not a great candidate for 3D printing. Now let's look at this last one here. This is sort of like a truss system here. It is incredibly thin. It is not non-existent. It definitely does have mass to it. It is just very thin. It also has, on these other points, it comes down to a single point in space that it would need to sit on the build plane. There's also just tons of negative space in here. 3D printing does really well with objects that have a lot of mass to them, things that are pretty solid. But let's export it and see what it would look like, and show you a couple more issues that this is going to have. If your object comes in like this, where it is gray and yellow striped, that means that it is outside of the bounding box. So I'm just going to need to click on it and scale it down just a little bit. There we go. If we slice it up, you're going to see that each one of these is going to be just a single dot of plastic. That's how thin it is. That means that the 3D printer is going to attempt to just stack single dots of plastic on top of themselves to create this system. I'm not saying it won't work ever, but it very likely will not work. Also, this system of laying down brims and building up single connection points is a little bit sketchy and might not work. I would consider other ways of building this, where possibly, if I really did need to 3D print this, possibly split it down this line right here, lay both of these objects flat, and then print them that way and rejoin them together after they're printed. But there you go. It's just a couple of examples of things that are good and not so good to 3D print. I encourage you to try whatever you need to. And then if you have any issues, don't feel afraid to reach out and see if we can't find a way to get something 3D printed for you.